OpenAI just stopped being only Nvidia's biggest customer and became its rival. On the 24th of June, it unveiled its very first chip ever, codenamed Jalapeño, and it's aimed straight at the part of AI that quietly prints the most money. Let's be precise, because the headlines are already overheating. OpenAI did not build a do-everything supercomputer that makes Nvidia obsolete overnight. What it built, together with Broadcom, is a custom inference processor, a purpose-built ASIC that OpenAI is calling an intelligence processor. Its one job is running large language models. The moment you type a prompt and wait for an answer, that's inference, and here's the line that matters most. Jalapeño is not built for training. Pre-training the next GPT, the brutally expensive part where a model learns from scratch, is still expected to lean on Nvidia hardware. So this is a targeted strike, not a knockout punch. Anyone telling you Nvidia is finished hasn't read past the headline. Quick definition, because these two words get blurred constantly. Training is school. You feed a model oceans of data and it slowly learns. That happens once per model, costs a fortune, and demands the most flexible, most powerful hardware money can buy, which today means Nvidia inference is the job. The trained model is on the clock, answering questions. A chip built only for inference can throw away everything training needs and optimize ruthlessly for one thing, serving answers fast and cheap. That narrowness isn't a weakness here. It's the entire point. But don't let inference only fool you into thinking it's small. Inference is arguably the bigger long-term prize. You train a model once. You run inference billions of times a day, forever. Every single time anyone uses ChatGPT. That's where the real recurring compute bill lives. And right now, OpenAI pays a giant chunk of that bill to Nvidia. A chip that does inference cheaper in OpenAI's own data centers, tuned to OpenAI's own models, hits Nvidia precisely where its most durable revenue comes from. That's why this matters, even though training stays put for now. Think about the math from OpenAI's side. Every free user, every paying subscriber, every API call routed through its models is an inference event, and each one costs power, silicon, and rack space. As usage climbs, that cost doesn't level off, it compounds. When you're renting that capacity on someone else's chips, your single largest variable expense is set by a supplier's price list. Owning the silicon flips that equation. You spend up front on design, then every query you serve on your own hardware shaves margin back into your pocket instead of Nvidia's. At OpenAI scale, even a modest efficiency gain per query, multiplied across billions of queries, is real money, and it accrues every day the fleet runs. So who actually built it, and how? This is a split job, and the split tells you a lot. OpenAI did the design. It architected the chip around its own models and how they actually run in production. Broadcom did the silicon implementation, turning that design into a real, manufacturable part. And it's a big one, a massive reticle-sized ASIC, meaning it's pushing right up against the physical size limit of what a chip can be. Two more names are attached to getting this into the world. Celestica and Microsoft are named as deployment and industrialization partners. The companies helping actually build, rack, and run these things at scale, so this isn't a science project. It's an industrial supply chain forming around OpenAI's own silicon. That division of labor is the smart part of the story. OpenAI is not pretending to become a chip foundry overnight. It's doing the one thing it understands better than anyone, how its own models behave under real-world load, and handing the brutally hard physical engineering to Broadcom, which has done custom silicon for the biggest names in tech for years. Celestica handling industrialization and Microsoft in the deployment mix tells you this is meant to be manufactured and racked at volume, not framed and hung on a wall. When four names that serious line up behind one chip, the intent is production, not publicity. Now the genuinely jaw-dropping part. The development speed. OpenAI and Broadcom say they went from design to manufacturing tape-out. That's the moment a chip design is finalized and sent to the factory in roughly 9 months. For a high-performance reticle-sized ASIC, that is absurd. Cycles like this normally run well over a year, often closer to 2. The companies are describing it as possibly the fastest high-performance ASIC cycle ever. And there's a twist that's very on-brand for OpenAI. They say they use their own AI models to speed up parts of the chip design. AI helping design the chips that run AI. Whatever you think of the hype, that feedback loop is real, and it's a preview of how this whole industry is about to move faster. And keep that possibly the fastest ever in the right column too. It's the company's own characterization, not a verified industry record. Tape-out matters because it's the point of no return. Once a design ships to the factory, fixing a mistake means months and a fortune. Doing that in 9 months on a chip this large normally takes a huge seasoned team and a lot of nerve. If AI tools genuinely compress parts of that, the interesting implication isn't this one chip, it's that the design cycle for the next one and everyone else's could shrink too. That's the loop worth watching. Now let's talk about the performance claim, because this is where you need to keep your guard up. OpenAI says early internal testing shows performance per watt, basically how much AI work you get per unit of energy, is substantially better than current state-of-the-art. Sounds incredible, but read that carefully. This is a vendor claim. It is self-reported. There are no hard numbers, no named comparison hardware, and no independent benchmarks. They didn't say X% better than an Nvidia H whatever. They said better than state-of-the-art and left it there. A fuller technical report is promised in the coming months. So let me say the unglamorous truth that a lot of channels won't. This is not a verified record. It's a promising claim from the people who built and are selling the thing. Until someone outside OpenAI measures it, treat the number-shaped hole where the benchmark should be as exactly that. When the technical report lands, that's the moment to get excited or get skeptical. And notice the exact shape of the wording, because it's doing a lot of quiet work. Early internal testing, substantially better than current state-of-the-art. That's a sentence engineered to impress while promising nothing falsifiable. State-of-the-art compared to what? Last year's hardware? This year's? A chip nobody can name. On which models? At what batch size? Under what power envelope? Every one of those blanks is exactly where a real benchmark would live, and every one is empty. None of that means the claim is false. It means it's unverified, and unverified is not the same as proven. The honest move is to write it down in pencil and wait for the report. So where does Jalapeno actually fit? It slots into a much bigger plan you may already have heard about. Back in October 2025, OpenAI and Broadcom announced a build-out to deploy 10 gigawatts of OpenAI-designed accelerators. That 10 gigawatt number is not new. It's old news from last year, and some coverage is quietly recycling it as if it broke this week. The genuinely fresh piece here is the chip reveal itself. Jalapeno is the silicon that fills out that plan. Its first production deployment targets gigawatt scale I noticed the word targets. Gigawatt scale is a goal with a date attached to rack. Not racks humming in a data center today. The chip is real and taped out. The fleet is still ahead of us. It's worth holding those two timelines apart because they get mashed together in a lot of coverage. The 10 gigawatt ambition is the destination, announced last October. Jalapeno, revealed on the 24th of June, is the vehicle. And the very first leg of that journey, gigawatt scale beginning end of 2026, is still a plan on a calendar, not hardware you can point to. So when you see a headline implying OpenAI just lit up a giant chip fleet this week, mentally separate what was announced. A real taped-out chip from what's promised. A fleet that starts deploying months from now and grows from there. Both are genuine. Only one has actually happened. Let me zoom out, because the strategic picture is the actual story. Every major AI lab has realized the same thing at once. Depending entirely on one supplier for the most critical, most expensive input to your business is a strategic trap. Google has its TPUs, Amazon has Trainium and Inferentia. Now OpenAI has Jalapeno. The pattern is unmistakable. The biggest buyers of Nvidia chips are all quietly building escape hatches, not to abandon Nvidia, but to gain leverage, cut their per-query costs, and stop having their margins set by someone else's price list. Custom inference silicon is how you do that, and leverage is the word to sit with. Even if Jalapeno never carried a single production query, simply having a credible in-house alternative changes the conversation with your supplier. The customer who can walk negotiates differently from the customer who can't. That's why these chips matter strategically long before they matter technically. They're insurance and bargaining power as much as hardware. OpenAI joining that club, given how much it buys, is a louder signal than most. So is this the end of Nvidia? No, and be suspicious of anyone who says it is. Nvidia still owns training, still has CUDA, the software moat that keeps developers locked in, and still sells everything it can make. But OpenAI no longer needs Nvidia for everything is a real shift, and over time, real money moves on shifts like that. The honest framing is this: Jalapeno is a partial shot, not a replacement. A serious one, aimed at the most profitable, most repetitive workload in AI, from the single most important AI company on Earth. Watch for that technical report in the coming months. Independent perf per watt numbers will tell us whether Jalapeno is a quiet revolution or a well-marketed first attempt. Either way, the era where Nvidia was the only game in town is visibly ending. Stay curious, this is AI Unpacked.